So we're going to spend some time today talking about triangles. And the first thing we need to know about triangles is that we classify triangles, and we classify them in two ways. And the first way we do it is to classify by angles. So when we classify by angles, we have three kinds of different triangles we can look at. The first one being an acute triangle, which means that all three angles are acute. We have an obtuse triangle, which has one obtuse angle. If we had more than one, it wouldn't be a triangle, because that would be more than 180 degrees. And we have a right triangle, which has one right angle. Again, if we had more than one, it'd be more than 180 degrees. So those are the ways we can classify by triangles. We can also classify by the side length. If we classify by side length, we have something called the isosceles triangle. An isosceles triangle has two congruent sides. And it would look something like this. And I would mark that these two sides are congruent by putting my little tick marks on. An equilateral triangle of course has three congruent sides. And these are the ones you're fairly used to looking at. Let's pretend that's equilateral. But I would also show that it's equilateral by marking that all the sides are congruent. And the last kind is a scalene triangle. Which has no congruent sides. Okay. And again, I would not mark any of the sides to be congruent either. So it might be something like that. None of the sides are congruent. Lots of right triangles are either isosceles or scalene. Right triangles obviously cannot be equilateral because then not all the angles would be the same. Which leads me to my next point, is that sometimes we can classify triangles by both side length and by their angle. So we could have an acute equilateral. In fact, all equilaterals are acute. We could have a right isosceles. We could have an obtuse scalene. We could have an acute isosceles. And so on. Okay, there's lots of different ways to do that. Okay? And all of these classifications help us to build what we call the triangle inequality theorem. Okay? And the triangle inequality theorem is like super important. Because it says the following, The triangle inequality theorem states that the length of the third side of a triangle is always less than the sum of the other two sides and greater than their difference. So if I have a triangle and I have three side lengths and I want to see if it's a triangle, which will be how the problems are presented. If I can add the two side lengths and the third one is less than that, I'm good. And if I can subtract the two side lengths and the third one is greater than that, it is a triangle. Otherwise, it is not. Okay? So we're going to play with some examples so we can see if what we have is a triangle. Okay? So let's say we're starting with a triangle with sides that are 2, 6, and 9 meters. Okay, and I want to know, does this triangle work? Okay, so how I would do that is I would play with the side lengths. And the one I really need to test is the biggest side length. So the biggest side length has to be less than the sum of the other two. So I need 9 to be less than 2 plus 6. Then we have to say 2 plus 6 is 8 meters. Is 9 meters less than 8? No, that does not work. So therefore, this is not a triangle that we can use, okay? Not a triangle. It might be something else, missing a side or something, but it's not a triangle, okay? On the other hand, what if we say we're looking for a triangle with sides that are 3, 4, and 5 inches? Does this triangle work? Well, again, I'm going to take my biggest side, 5, and that has to be less than the sum of 3 plus 4. 3 plus 4 is 7. 5 is less than 7, so that's good. And then I also have to say it's greater than their difference. And is 5 greater than 4 minus 3? Well, 4 minus 3 is 1. So yes, this works too. So therefore this triangle works. Okay? So I'm going to give you one to try on your own.